Spotify is very much experiment and data-driven. Anybody working on features is using the platform indirectly. So we get traffic from all over the place. Like every client pretty much hits our systems in the end.
Welcome to Nerd Out at Spotify, where we bring you behind the curtain of the world's most popular audio streaming subscription service. Machine learning, open source, clouds, tabs versus spaces. We'll talk to Spotify engineers about interesting tech issues, big and small. I'm Dave Zolotusky, principal engineer at Spotify. And if you're listening to this episode the day it came out, you're getting to hear a first for this podcast. Breaking news. Today, Spotify announced that we're releasing a new product for software development teams, an experimentation platform called Confidence. You can read the announcement on the Spotify engineering blog. Confidence is based on the homegrown experimentation platform we use every day at Spotify. We built it so that any team could easily set up and run their own experiments. But it wasn't the only experimentation tool that we've ever built. Last episode, we talked about ABBA, our first A/B testing platform, which we used for years. We used it to test UI changes, new features, content recommendations, everything we could think of. It was great, until it wasn't. The more we used ABBA, the more we ran into its limitations. It was too easy to mess up your tests with manual configurations. Coordinating treatment groups was still tricky, so one team's experiments could mess up the results from another team's. Tying every feature to a feature flag made both testing and releasing features more complicated than it could be, and on and on. All along the way of using ABBA, we've been learning more and more about what makes an experiment a good experiment. And after years of improvements and workarounds, we finally asked ourselves, if we could start over and build the ideal experimentation platform from scratch, what would that look like? So that's what we did. We set out to replace ABBA with something better. But of course, that's easier said than done. Mark Gray joined us again to tell us about how we built a newer, better experimentation platform, the one that we still use at Spotify today. And he's joined by Dima Kunin, the guy who finally pulled the plug on ABBA. Hey, Mark. It's good to have you back.
It's good to be back.
And we're also here with Dima. Dima, can you tell us a little about yourself and what you do at Spotify?
So I'm a senior engineer in experimentation platform product area. What I do is different on different days, from design docs and development to very fun dig into some issue for 3 days. Why doesn't it work? Investigations. Been with experimentation for 4 years. That's how I met Mark. I remember that day still. And before that, I did a bunch of Android development and some car integration. So in total, 8 years at Spotify.
Tell me, why is the day that you met Mark so memorable?
You met Mark before. How can you forget Mark? Mark is one of the nicest people at the company. You can never forget Mark.
Thanks, man.
I'm sorry to say that, but that makes a mark in your life.
And with that intro, I guess, Mark, can you give us a quick reminder for those that didn't listen to episode 20, who you are and what you do here?
Of course. Yeah, my name is Mark Gray. I am a senior staff engineer in the Learning Infrastructure Studio. It is the part of Spotify that provides all the different tools that kind of help us do applied data work. So things like machine learning, analytics, and also experimentation, where Dima is joining us from today. So it's kind of like the applied forms of data work, one layer above the raw infrastructure for like data processing.
We dig deeper into that back in episode 20. So let's keep going. You both talked a little bit about experimentation. I think you called it experimentation platform. PA is the part of the company where Dima is. Can you tell me a little bit more about what that actually means?
A PA, I guess you can say, it's a bigger group of people solving a bunch of related problems. So in this case, it's solving experimentation at Spotify, from feature flagging to setting up experiments to metrics. So our experimentation product can be split into major pieces such as a feature flagging system that you integrate in your code to switch between different behaviors of the application. The famous button example, like a thing that makes your button red or green or whatever. So you have the feature flagging team, and then we have feature flagging SDKs for multiple platforms. So we have actually 2 teams. And this feature flagging needs to be served by some system, which is also one of these teams. Then when you set up experiments, you need some sort of scheduling, coordination, experiment setup flow that sort of ties everything together. Basically, that's a place where you say, this feature flag should be this value for these people. And then metrics that make experimentation useful. that you also tie together with feature flags. Like for those people in this experiment, measure this 10 things and do it in a statistically meaningful way. So it's real stuff and not made up numbers.
The one thing I'd call out here is this group that it makes up the experimentation PA that Dima mentioned is the organizational artifact that graduated from those efforts in the last episode. So where we used to have one team that would manage bits and bits of all of that and kind of only had the bandwidth to do initiatives in maybe one piece at a time, we now have a quite large organization within the Learning Infrastructure Studio that works on all fronts of experimentation, which is pretty cool. It's kind of all the way across the stack now.
That's actually exactly the thing that I wanted to dig into a bit, because I remember we talked before both about ABBA and about what seemed like a pretty scrappy group that put ABBA together and then kind of built into a single team running. Maybe it wasn't quite a single system, but it sounded like a reasonably straightforward setup. And then Dima just listed, I don't know, 6 like different seeming areas, and it just sounded much more complex and elaborate. So I'm trying to figure out like how we went from the end of the last episode to the beginning of this episode and all those things happened.
Yeah, so I think where we left off with the history of ABBA, there was sort of like a few important forces were combining to make us realize that we needed a better set of abstractions to deal with experimentation. And those were the proliferation of platforms. Just we're on so many different devices with different kinds of experiences and different properties of the user experience. There was a big push into content-based experimentation, like experimentation in the homepage serving different content, where the targeting needs got a lot more complex, the need to manage exclusive experiments, the need to coordinate holdout groups and things like that. And then finally, like the rigidity of our prior metrics offering. Like it was really hard to add new metrics. Really, the central team had to do that on behalf of other Spotifyers. So I think those 3 things were the big forces that kind of combined into what became a small group of people hacking on, like, if we were to just pull up the floorboards and rethink how we're actually serving this, kind of greenfield it entirely, what would be the like domain objects we'd put in the system? And I think that's some of that thinking is kind of captured in the structure of the teams today, although we didn't really know at the time that it would be the right one. I think where things kind of spun off from there was a small group of folks, myself among them, got together to kind of hack in Stockholm for, I think it was a 2-week period. And at the time, I think the big thing we were focused on there was a lot of the problems with configuration, reliably delivering those feature flags Dima mentioned was the first thing that we really thought about and tried to kind of ideate many, many days worth of whiteboarding sessions till we got to something that we felt confident about trying. And then from that, we sort of branch out and find people who are passionate and interested in working on each piece of this. So, folks who would be comfortable representing the metrics side and that initiative, as well as the test coordination pieces.
I think at the end of the last episode, we talked a bit about just scaling to the sheer number of users we had, things like moving to cloud, which created a whole lot more data. You mentioned a bunch of different platforms. I think those sorts of problems, I kind of conceptually understand what that means and roughly how that could stress a system. But then you just talked a bit about, I think one of you mentioned holdout groups. You mentioned content-based experimentation on home, things like that, making it easier to do metrics. And you just mentioned configuration reliability. Can you walk me through a little bit of like what those problems mean and how we started trying to solve them on ABBA and then knew that it just wasn't going to work?
Yeah, so a holdout group in the targeting layer is really a scenario. I think we talked a little bit about it in the last episode, but not much, where you want to retain a group of users apart from an experiment. It could be many experiments, it could be one particular experiment, but you need users to not receive the experience so that you can use them as a control group or the basis of another comparison in the future. And that's sort of like controlling at a granular level who's included in what experiment is pretty important. It can be used to coordinate things like experiments that you would reasonably expect conflict with one another. It can be used to kind of assess seasonality in the metric that's being measured. It can be used for a lot of different things. But this kind of like breaking out the ability to withhold people from experiments became pretty important once we started getting into really diverse experimentation domains like content, where an individual user is going to get a personalized experience that's different from another user. And the way we handled this in ABBA was really pretty manual. It was based off coordinating all the random number generators with the same salts, kind of composing the tests into a tree that would have to be managed by the person instrumenting the tests. So the team would have to get it right, and it was pretty hard to get it right.
So yeah, so you would end up kind of individually needing to figure out which experiments need to not conflict with each other and how you need to hold people out from them, and then use with random numbers and stuff to do that.
At a super basic level, even like a bunch of nested conditionals, if else type statements that actually need to be composed reflecting that. So it leaves a lot of room for error in an experiment, which typically we would associate with a nice controlled environment that minimizes the chances of error. So I think that was a pretty painful thing for our users, and also just became even more and more of an important need as the needs around A/B testing kind of evolved.
And then let's see, what was the other couple of things? You talked about content-based experiments on home. Why was that such a hard thing for a system like ABBA? And we knew we needed a whole different thing for that.
I think so that falls into a lot of the requirements there fall into the same space. It's controlling eligibility in a granular way. And the targeting criteria just tend to be a lot more complex. You'll have users in different groups that you want to serve different content to, but maybe targeted experiments on things like age or things like their market. But generally, I think those two pieces kind of fall within the same heading of orchestration.
Then maybe I picked a bad one. I don't know. You talked about configuration reliability, maybe. Was that like an ABBA thing, or am I asking the same question over and over again?
No, I think this is a valid one. Yeah. So just configuration reliability is just a matter of like we didn't have reasonably consistent SDKs for ensuring that the user experience that was defined in the experiment was delivered to the end user, and then also exposed. So a lot of the stuff that came up in this context was things like, different preloading behavior on different platforms might cause an exposure where the user hadn't actually seen the experience, or in other instances where like different behaviors in terms of timeouts might give up and default sooner on one platform than on another platform. So we really wanted to kind of put some strong guarantees in place on a lot of that. We structured it a lot more deliberately across platforms in the new experimentation platform.
Early on in your answer, you said preloading behavior on different platforms can cause an exposure. I think half of those words might not mean anything to someone that isn't like living in this world. Can you explain what preloading behavior is and what an exposure is, and then why one causes the other sometimes but not other times?
Dima, you want to have a crack at that?
Preloading exposure. Yes. I like an example of buying bread versus eating it. So you get a loaf of bread and then maybe you eat it, maybe you don't eat it. Ideally, we know that you've ate it, and then we say you've been exposed to bread. So, and there is different rates of exposure from, true exposure, we call the ideal situation when we saw that you ate bread, but it's not just you ate the bread, but it also got some effect on you, which is really hard to achieve this true level of exposure. So that's the one absolute sort of like knowing for sure that you ate the bread and it had an effect. And then there's less true exposure when we say, if you bought the bread, then you probably ate it. We don't know. But maybe people buy bread to build their houses out of that bread. Who knows? Then let's say bread is instead of a bread, this is experiments that user been into. And we serve them values of these feature flags and these experiments. And then we sort of just served it to them. And we make an assumption that they've been affected by these experiments. That's like making an assumption that they buy bread and they eat bread necessarily. That makes weak guarantees that they've actually been affected by this experiment, versus a stronger one when we, for example, wait for them to see a particular screen somewhere in the application. And then we say, okay, you've seen this search screen, for example. Then you quite likely have been exposed to the result of this experiment. So there have been constant journey into improving this and making the exposure truer. So for exposure, we always want people to eat the bread, and we look at them when they eat the bread, and we take tests, and we're like, you actually ate the bread. That would be the true exposure. So we improved a lot on that front just by providing, you can specify data set that points users who ate the bread. We emit events in particular moments in application, which we think are very close to the moment when you ate the bread. And then the other aspect of this is so we improved our bread eating detection behavior a lot. We developed even a special library that's called Exposure Leap for even more intricate bread eating behavior, so that our users can say, this is when the bread was eaten. And then the preloading stuff, previously we would deliver experiments with the application, basically. So you would have your app installed, and that had all the definition of the experiments. And from that, today we deliver all the experiments remotely. So the client has to download all the experiment definitions, which means we can change them whenever we want. We can switch the behavior of the application when it's been released.
But one other thing that you guys mentioned is that in the ABBA world, it was much harder to add additional metrics, and that was one of the things we wanted to do. Tell me a little bit more about that, because I guess in my head, I feel like we probably have, I don't know, let's say 10, I don't know what the number is, but like some collection of key metrics, like amount of times that person used this or number of times they streamed the track because of the button color or whatever.
Yeah.
And those are like the key metrics you would go for. Why was there suddenly an explosion in the number of metrics we needed beyond what we had kind of easily available in ABBA?
This is a great question because it gets into some of the important aspects of good experiment design. But to kind of summarize, we do have those kinds of top-level sanity metrics. They're both core company metrics like monthly active users, consumption time, and minutes, as well as some like guardrail metrics around like errors and the overall stability of the app. So those are tested automatically. I think in the ABBA days, we only had those in place. And to give an example of what might be a metric that's closer to a team is when they're trying to optimize their own smaller, sub experience within the app. So one that comes up a lot in this context might be something like the amount of consumption time from, curated content. So we want to know how our content curators who design playlists like Rap Caviar, how good a job they're doing as they add new tracks and things like that. Or maybe we're changing the experience to introduce a new experience in Rap Caviar. There's a video experience now or something. We want to optimize the amount of time, like the ratio of time that's streamed from that curated content as opposed to just other discovery mechanisms like maybe search. So it's pretty common that teams will want to have those types of metrics that speak more naturally to like the work they're doing in their team. But there's always a little bit of push-pull there. And so far as like you want to make sure that that's also a net positive for all of Spotify, as well as that you're not optimizing for a signal that kind of causes harm elsewhere in some other part of the experience. But that kind of granularity, it's really driven by the fact that like moving top-level metrics like monthly active users is very hard with small optimizations that would be made by a typical team that could be delivered iteratively. It's very hard to move those. The horizon line on them is a lot longer. You wouldn't really expect the small kind of incremental change we want to do to move something like overall consumption time around the world. It's great if it does, but it's rare in practice because we've been around for many years now and have done a generally good job of optimizing our user experience. So yeah, that kind of is what fed the need to record more diverse signals so we could tell a better story about the things we're trying to detect with our hypotheses and measure them, because it's also the case, like as the business domain changes, we might change the things we're measuring.
That makes a lot of sense, but it's 100% not something I would have initially thought of. It's, I guess as the company grows and as the user base grows, like a lot of these metrics don't change with every experiment, but you need some way of knowing the outcome of the experiment. Is there like some, I don't know, Cliff Note sheet or some place where it's like, these are things that make good experiment design that people like Dave would not have thought of?
I think we try and bake most of that into the experience in the platform now so that we try and give good warnings and detect things before they happen and let users know where they might have like a configuration conflict with another running experiment. We try and prompt that. It's part of the experimentation platform proper.
So yeah, I guess let's start digging into the new experimentation platform. And my first question was really like, okay, great. Now we've figured out that we need to do this. We've figured out that there are a bunch of changes at the company that have rendered ABBA kind of not good enough. How does what seems like a very drastic, almost like all impacting change happen at Spotify? Like, how do we do this?
I think one of the nice things about Spotify and its culture is that very often those kinds of things can start as a reasonably grassroots movement, for lack of a better term, amongst people who are directly working on the platform and trying to improve it. In the particular case of experimentation, we did get together, sort of mentioned before, the smaller group of people, I think it was around 3 or 4, who were reasonably well familiar with the problems, at least with the feature flagging stack initially, and try and think about if where this really began was on a whiteboard saying, if we were to separate the experiment definition, right? So like how the randomizer actually assigns the population of users it's observing from the configuration, which is more abstract concept of the inventory of things we might change in the application, be it, recommender algorithms, button colors, anything really. If we were to separate these two abstractions, kind of make one compose the other and produce the other, how would that change, the things that we were seeing to be quite inflexible in ABBA at the time? especially with regard to that targeting portion. So if we could coordinate experiments apart from what actual experiences they produce, that was one thing that we started ideating on a whiteboard at that point. And did some hacking on it, assigned some real users via this approach, in a very small, constrained environment. And then from there, kind of grew that initiative, towards other portions of the experimentation stack.
Do you want to dig into a little bit of like the actual building this thing? How'd you kind of start from ABBA and end up at some system to start replacing ABBA with?
I think early on, so from that small hack group, we sort of realized we want to spend at least up an effort around feature flagging, improving that. I think at this point, we're maybe still assuming that we'll be repurposing portions of ABBA's SDK, although we left open the option that we would greenfield that too. And that's when we start gathering together folks who have like a lot of experience with the client ecosystem. The team was largely like backend and data people initially. So we pulled together some folks who are very familiar with like our mobile application environments, both on Android and iOS, which was a real game changer, bringing strong, background with that, because those are the places where we actually have to deliver these configurations. And around the time when that team is kicking off is when Dima joins us to work on the backend, like configuration assignment portion.
So the team was very cross-platform at that stage. So there was, like Mark said, mobile for iOS and Android. There were web people, backend people. At the time when I joined, we had some backend service, but it wasn't serving production traffic. And we were just starting to integrate with the main Spotify application for the SDKs. So we have Android SDK, iOS SDK, web SDK, and multiple flavors of backend SDK. And mobile integration, it serves the most experiments. I would dare to say that it's probably 700 experiments for a mobile app. So that's where most of bread-eating exposure happens in the application in terms of how many, like experiment density sort of. So mobile integration were really important to get early to work and reliably. So that's where we spent a bunch of time. Integration took time because we integrated not from scratch, but with a big application that's been running for, 10 years at that time. So that was, that took time. Then we did a bunch of work on the backend, and the backend needs were quite diverse. Some people care a lot about latency for their experimentalization. Some people don't. If you were in a request pass from a user that is responsible for playback, then you don't want to fail that request pass. So we had to do a lot of configuration fallbacks scenarios, like what Mark talked a little bit before. So before in ABBA, if you can't reach ABBA, you don't get any values for your feature flags. And that could sometimes lead to somebody not handling the situation well and the entire client crashing. So the previous system would be less reliable in terms of not availability of the system serving the experiments. The new system had a very different abstraction for feature flags. That's why we actually call them properties, because they're very different. So there was a lot of work on integrating stuff and making it more reliable, pretty much. And so it doesn't fail even if people do something wrong, quote unquote.
Tell me a little bit more about that. You said properties versus feature flags, and you said they're very different.
Yeah, so traditionally feature flag is like a configurable point in the application. It's usually just expressed as like a simple on-off Boolean. And it's some branch in the logic where we might reconfigure a button color is kind of always the canonical example we go for. So maybe a green or a red button. And usually the person building the test like instruments that part of the experience based on that flag that comes back.
What's so special about properties?
They are so special. Our properties have a lot of special things about them. So we tried to extract what you usually have in your code, like variables that control behavior, into something that could be controlled remotely, so not from your code execution. So we usually had, an integer for the button size, then you would get this integer from the backend. If you compare it to normal, like a more standard approach to feature flagging and how you deliver experiments, then a client asks a backend, like, what experiments I'm in, this kind of stuff, right? And then they're like, okay, you are an experiment, let's try this biggest ever button so we can finally have the perfect buttons. We use the button example so much, we probably have the perfect button size and color. So often a client will ask the backend to say, like, what experiment I'm in? And then client is aware of this experiment. It knows that in case of the biggest ever button experiment, the client needs to set the button size to a particular value. We changed that abstraction so that you say, I have a variable button color, and that variable is controlled from a backend. We don't know if it actually is controlled by experiment or rollout, or it's not controlled at all, because these properties compared to feature flags, they always have a default value and actually some range on top of that, so you can't assign some improper values. That means that if you can't receive your button size from the backend, you fall back to a meaningful default. And then we also log exposure that you had fallen back to a meaningful default. And we will exclude this data from experimentation analysis, for example. So that's, I think, is what's special about properties. They encapsulate more like branching behavior in the client, and they are not experiment aware directly, and they hide experiments behind them. So we know how to map experiments from properties and back and forth.
So there are other bits of the actual like initial build of the system that come to mind as really interesting points or like interesting design decisions you guys had to make around then?
I think a big one is in the metrics layer. So as I talked about in the last episode, we had now benefited from, the scale of the cloud. So we could do a lot more complex things with much less engineering time and much less time spent into baseline of like managing infrastructure. So we built out that original metrics offering in ABBA that would just compute the company key metrics. But what was added was a more flexible system that probably today would be pretty conventional, done in DBT or something like that, but allows you to bring a materialized table that would be user level. And then we could join that and any values that you had expressed in your materialized table to produce like continuous or bivariate metrics. So we could say like, okay, your metric that you have of interest is that consumption timed from curated content. Let's say you would do your filtering with some SQL to produce only users and the amount of curated content they had listened to or how much. And then that would be joined into the system, joined with the experiment exposure, assigned into the groups so that our analysts and our data scientists who are examining experiments effectively, all they'd ever really need to do is bring us a table of user IDs with the value to be combined. And it created a much more flexible environment. And then we on our end would allow the system would basically just manage the grouping and the statistical tests for them. So this is how we ultimately built out like a more flexible metrics offering and then integrated that with the front ends and the reporting so that like you bring us a data warehouse table, we bring you back ship or no ship on your experiment with some insights as to how it performed.
One thing I think both you and Dima have mentioned a few times, like the concept of these experiments being statistically significant and like the statistics being valid, like it sounds like that was kind of an undertone through a bunch of this where we had a lot of issues with experiments and a lot of the new platform either did or strived to fix a lot of it. Can you just dig a little bit more into what that means, why it's a problem, and how we made it either not a problem or less of a problem in the new platform?
So I think just within the realm of applying the statistical tests, there's always things here that would be the same in any experiment environment, whether it's like clinical trials or A/B tests in a big tech company. And that's stuff like collecting enough sample to make sure that the test is meaningful, make sure that's powered, just basically everything that would control for the situation where we would accept the wrong hypothesis. Have we collected enough data? And that's sort of invariant. Like those are things that we could check just given the people we've collected and knowing what tests we're applying. I think the problems that we had to solve underneath that are sort of more unique to some of the things that had surfaced with ABBA had more to do with just the environment in which we're operating this thing. So a lot of the configuration reliability stuff would in some instances result in, treating as sampled users who had no interaction with the test. They didn't eat the bread, and then they become noise in the sample. Or in other instances, collecting too much sample from a population that maybe isn't representative of the whole or allowing a different variable about their experience to oversample for them. So some of the things that may come up there is like instances where maybe the experiment was instrumented in a particular way where you could only reach the exposure experience if you were in another unrelated experiment. And then you have this kind of coupling between two things that doesn't allow you to actually test meaningfully for the latter one. So these are the kinds of things that, I guess the analogy I would use there that came up a lot at the time was like random sampling, right? You want to make sure that in your clinical trial, you don't overrepresent people by accident who might have comorbid heart disease. And so that's like the kind of environment
to go
here.
with a light one.
It's a real light one, yeah. Oversample for people who maybe got this one experience in another person's experiment, right? Because you're going to get some of them if you're randomizing over them. But the hope is maybe Dima's horrible experiment just really makes the experience bad. But ideally, I only get so many people from Dima's experiment. many more people from all the other experiments, and then, sort of fuzzes itself out in the analysis. But in certain instances, like the way the test is instrumented could confound that. So these are the types of things that we really tried to make much more opinionated and hopefully capture to some extent remotely in the remote configuration offering. And that's some of the thinking that led to surfaces.
And surfaces would be like in similar like PAs, it's a portion of Spotify, not exactly in the same application, that are solving the same user problems. I think it's easier to understand if you use example. One surface is search, basically all of the search, or there are more technical surfaces like infrastructure, or their home screen surface, and there's many more surfaces, playback surface, and so on and so forth. And usually people in these surfaces, they would conflict potentially their experiments, like they don't want to change too many things on search at the time. And that's where we have the big portion of hydrogenation happening. Like we wouldn't as much coordinate experiments between, let's say, search and backend infrastructure, because they are not affecting the user in the same dimension. But we would need to do a lot of per surface management with exclusivity groups and holdbacks, the users who are not in any experiment, and we use them as we deprive them of all bread for 3 months. And then we see this is our ultimate control group, and let's see what happens if people don't eat bread for 3 months, and maybe all the bread we have given them is actually bad for them, or hopefully good. We like to make a good bread. So Mark mentioned Vron experiment setup. There are, I guess, preventive mechanisms for setting up a Vron experiment, like running the sample size calculation, just making sure your population on the right size. But also we have a bunch of checks after the experiment has been started. The most infamous and common is sample ratio mismatch, which means that let's say you had an experiment that gives 50% people red buttons and the other 50% get blue buttons. But then you see in actual assignments that actually 90% people received red buttons and 10 received blue buttons. So there is a mismatch between what actually happened and what you planned for experiment. And that could be a platform issue, but usually it's not. Usually it's something that when you, let's say in a treatment itself, you change how you log the exposure. Maybe when you have red buttons, you log exposure more often, and you don't log it at all when you have blue buttons. That's a simplified example, of course. They could be maybe your experiment is showing some sort of screen in treatment and not showing it in control, but you log exposure only when you show the screen. That means you will only have exposure for the people in the treatment group. So that means you can't analyze anything at all, because you only have the data from the treatment group.
Talk to me a little bit about actually running this thing. Like you talked about all these SDKs and different platforms and very different needs, whether it's latency or, I don't know, anything else. Tell me what that was like, kind of going from nothing to operating this scale and this important of a service.
Yes, I waited for this question. Just wanted to say that we went from 0 requests per second to, looking at the dashboard now, 3 million requests per second concurrently for the system. And that's only those that are online. We are one of the most loaded services at Spotify, if I remember correctly. At least we are in the top 3 and probably top 3 for the number of events we produce. So because Spotify is very much experiment and data-driven, anybody working on features is using the platform indirectly. So we get traffic from all over the place. Like every client pretty much hits our systems in the end. How did it go from 0 to this? We did some funny things like dark loading the system, originally giving it more traffic from the production, gradually more and more. Specifically for the backend integration, it didn't go from 0 to 2 million, because the more systems we're integrating, the more traffic we get. And then that naturally led to a gradual rollout. But of course, the system evolved a lot through the time when we had 10,000 requests to 3 million requests. There have been incidents, of course, in that, some fun things.
Tell me more fun stories, whether it's incidents or anything else, but fun days in the history of this thing.
So we did renaming. We wanted to change a bunch of internal protobuffs, you can say. Like when you have an experiment, you have treatments where you put the users or whatever they are in. And there have been so many names for this over the time. They've been called variants, they've been called groups, they've been called policy groups, they've been called treatments most recently. And at some point, we decided to make it better by renaming it again, of course. At that time into treatments, I think.
This one will be the right one. I'm confident.
We need to run a test on that, yes.
As always, there's an XKCD about this.
So we made a bunch of protobuf changes, and we ended up with a couple of fields in the protobuf. One of them was called group IDs, and one of them was called policy group IDs. And we had a practice that the mobile people in our team, they were really keen on doing mob programming, and or iOS and Android, they would work together on one platform and then do a change on another platform. So at some point, it turned out that we put wrong integers into one of the fields instead of policy IDs. Policy IDs went into group IDs, and group IDs went nowhere. So we were basically not logging exposure for 2 weeks properly because the name of the field was wrong. And so it happened that because the mobile team was mobbing on that, the same problem was reproduced on both platforms. We actually managed to recover the data. That was quite cool work by other guys in other team. They managed to reproduce the allocations. Like, we knew that the users ended up in this experiment. We just didn't know in what group. So we managed to rehash them. So we took their users' IDs and applied our sampling function. So we could recover from that. But it's been 2 weeks of a little bit of pale faces.
I think another interesting story in this one, I think about it, is in both instances, both on the rollout of the new experimentation platform and in the final decommissioning of ABBA, we utilized this remote configuration capability to kind of roll out the change. So we shipped the new experimentation platform by way of one ABBA feature flag that gradually ramped up in number of people included. And we decommissioned the older one with a long-running feature flag in the new platform that gradually ramped down, which is kind of cool. A really extreme version of dogfooding. But that's also a really unique thing about this problem space is, the applications are installed on devices that may or may not update depending on the user's preferences. So it drives a lot of requirements in a big project like this where you're rebuilding that client SDK to have the old stuff available for a long period until it's end of life, whatever version is on the user's device. So yeah, that drove a lot of complexity in how we actually took it to production.
I can add on this just to illustrate how wonderful it is to have a good experimentation platform in this case. When we were deprecating ABBA, like Mark said, we were using the new platform to turn ABBA gradually off. And we got metrics from users who we turned it off automatically. We have some called guardrail metrics, this standard sets of crashes and time active in app and other stuff. So we could see that as we turn off ABBA for users to still somehow depend on it, it didn't affect them negatively. None of the metrics were affected. So we were able to decommission a system, a predecessor of the current system, with the new system, which I think is not the use case that people often think about, right? Like, usually you have feature flagging systems, so you roll out more and more stuff. But in this case, we used it to decommission safely without any negative experience on the users. So that was not just, it's going to be fine. Look, who uses ABBA? It was actually measured.
No, that's really cool. That was going to be my next question. I wanted to ask a bit more about how you actually decommissioned ABBA, and that gives me a good idea for kind of the high level of it. But I mean, how did it go? I imagine it wasn't just like, the first time you tried shutting things down, it all just went smoothly. All the graphs looked great. Everything went, I don't know, either up and to the right or down and to the right, depending on which of the two we're looking at. And everyone was happy. I imagine there was a little bit more to it.
First, it didn't happen immediately after we had a new system. The final decommissioning happened 2 or 3 years after we had the new system in 100% in production. During that time, ABBA was in something that's called zombie ABBA mode. And that basically meant that it had a snapshot of all experiments. You couldn't add new stuff, but you could still get served your old feature flags. And that zombie state, that was quite a resilient zombie, you can say. It was there for 3 years. And one day we basically okay, we would need to migrate this service to some new, Java SDK or whatever it was. Maybe we should just try to kill it. So we tried to do that. We basically started responding, I'm a teapot from the ABBA endpoint to some users and measuring metrics for them. Obviously, there was somebody else somewhere in the organization using some SDK to access ABBA from different endpoint, which we found not too late, but still, it was a surprise. But other than that, it took time, and it took, I think, a little bit of being brave because this thing has been around for so long. It also took a little bit of archaeological research because I found the apps from 2020 and 2019, I think. And again, bragging moment, they both still run, they both still play music. So I could really test manually. And that's like another cool thing with the experimentation platform. You can override yourself into a treatment, meaning you will force yourself to get a particular experience. So I put myself into the experience when I don't have ABBA anymore. I could test stuff and see like, okay, the app seems to work. And then we continued with turning it off for more and more users and looking at the metrics. And then after 3 years, we spent maybe a week. And then in a week, it was turned off.
I think we're pretty happy with this set of abstractions we have now, like separating experiments from config for that reason, because we did have a lot of these experiences that sort of validated that conceptual model, including shutting down the old system atop it. That thing about ABBA out there, like the Voyager spacecraft gradually receding into the distance, is one of the cooler stories to come from that whole effort.
I'm curious, like the individuals, I mean, even the people that were kind of creating experiments or operating them during that phase where they either had experiments running on both platforms or were slowly moving over to the new one, was that response generally kind of pretty positive and exciting to not have to deal with the workarounds? Or was there still like not necessarily feature-based, but just general resistance to migrating away from the thing that they kind of maybe not know and love, but know and have used for years?
I think it can always be challenging to ask teams that are working on end user features to make a infrastructural change to improve the overall platform. That's something that comes up a lot in platform mission at Spotify. I do think in this instance, though, there were for certain subgroups like new capabilities that this really brought with. So for like client teams mostly doing experimentation in the mobile devices, one of the big value adds was the ability to like reuse these configuration properties across experiments, redefine them, change the experiment remotely without having to wait for a client release. So like another release of the mobile application, that was a big one. And then I think gradually as we got more familiar with their needs and test coordination, that was a big value add across the board, not having to manage those spreadsheets and accurately reflect the spreadsheet into code was a huge win.
Dima, tell me a little about kind of the end of this process, like when ABBA was finally kind of done, when we had gotten through the zombie ABBA state, when we had sent everyone their I'm a teapot responses. How did we finally decide that we didn't need ABBA anymore? We were sure of it, and we actually, I don't know, shut it down, removed it from everyone's code, whatever the kind of final RF ABBA looks like.
Yeah, we had a celebration. We cried. Then we boarded the cruise boat and went to Hawaii and celebrated for 3 weeks. That's not true, unfortunately. But yeah, but we had a meeting. Yes, so we had a meeting. We archived the repository together. We removed all the capacity as we were shutting it down in terms of how much traffic it gets. Like many good engineering projects, it was quite boring in a way. Like we sat in a meeting. Mark was there. Other people from our team were there. We just sort of, okay, that's the last instance. Kill it. Let's archive the repository. Done. That was it.
This was during pandemic, so I didn't have the pleasure of traveling to Stockholm, which I had done many a time throughout the course of the project. But yeah, no, this was in a hangout session.
ABBA has a very good set of ABBA, the music band, not the service, has a very good set of tracks for that occasion. I think one of them, I'm not joking, it's called Don't Shut Me Down. So I think we've been playing that. And then there's Farewell or Goodbye. So
Sunset Club, yeah, there's a lot of them.
And that's one of the benefits of picking a really good band name for your service. When you decommission it, you can find funny tracks to play.
I think the greatest loss in us not having ABBA anymore is that we do not have an operational service with what is probably the best named service of any company I have ever worked at.
I agree. We should make ABBA too.
Cool. Well, thank you both for your time. This has been a lot of fun.
Thanks, Dave.
Thank you. It's been a pleasure.
Before we wrap up, I think I asked Mark this last time, so I'll leave him alone, but I'll make Dima tell me, what other things other than this work experimentation stuff, what else do you nerd out about?
I'm a new father with a really small child. And
congratulations.
Thank you. And my only hobby now is to sleep. And I only nerd out by looking at my sleep statistics and like, okay, how do I sleep more? But honestly, I do a bunch of hiking. I'm in Sweden. So when I moved to Sweden, I was like, okay, what can you do in Sweden? Which is also cheap and nice. You can go out and sleep in the forest. And that's what I do sometimes. Pretty nice.
Thanks for listening. You can learn more about Confidence, the commercial version of our experimentation platform that we just announced today on the Spotify Engineering blog. You'll find a link in the show notes. And I'm sure that we'll talk more about Confidence on a future episode. So hit that follow button so you don't miss it. If you have any questions or feedback, email us at nerdout@spotify.com. Nerd Out at Spotify is produced by Spotify's Ted Vergakis and by Seaplane Armada, who also wrote our unbeatable theme song. I'm Dave Zolotusky. Thanks for nerding out with us.